Hello student, today we are going to study about the equilibrium constant or the criteria of equilibrium constant. Let us talk about question at first. Deduce the criteria of equilibrium when temperature T and volume V are constant. Or the same question may be asked likewise. Deduce the criteria of equilibrium constant in terms of Helmoltz free energy. If such a question is asked, then we have to derive as follows. The criteria for equilibrium constant T and V is expressed in terms of Helmholtz free energy as A is equal to E minus Ts. This is equation 1. We want to differentiate this equation 1. Differentiating equation 1, we get dA minus T dot ds minus S dot dt. We apply here chain rule or product rule. Chain rule or product rule. When we apply product rule on ts, then minus ts, then we get minus t dot ds minus s dot dt. This is equation 2. When the process is reversal or the from the first law of thermodynamics, from the first law of thermodynamics, we get T dot ds is equal to dE plus P dot dB. Instead of dq, we put here T dot ds. Putting the value of A, this is, we suppose this as equation A. Putting the value, look here, putting the value of equation A in equation 3. Equation 2. Equation 2 is here, we put the value of A. We put the value of T dot ds, we put the value, putting the value of T dot ds in equation 2. This is equation 2. We put the value of T dot ds here. We put the value of T dot ds. Then we get the result. dA is equal to dE. And instead of T dot ds, we put dE plus P dot dB minus dE minus P dot dB minus S dot dt. And dA is equal to this dE and this term is cancelled out, then minus P dot dB minus S dot dt. Then we get d is dA. When this comes right side, left side, we get P dot dB. This is left side, S dot dt is equal to 0. This is equation 3. At constant temperature and volume, equation 3. This, when we take constant temperature and volume is pressure, at constant temperature and volume, we get like this. At constant TA, when at constant temperature, this term is 0. At constant volume, this term is 0. So the product result is 0. dA is equal to TB. This is for infinite small change, very small change, and this is for this del. This is A. This del A is equal to 0 for finite change. Here del A TB is greater than 0. This process is non-spontaneous and it does not occur. And when it is equal to 0, for this is for reversal process and the system is equilibrium. In equilibrium condition, we always use is equal to 0. Then the process, in such a condition, the system is reversal process. When the system is less than 0, then the process is irreversible and the system is spontaneous. Also, we can say that energy change is positive for non-spontaneous. Energy change is positive. If energy change this is positive, means greater than 0, then it is non-spontaneous. It's similar case is written, we have written here, and this is the conclusion we have written. When the energy change means this when energy change is less than is negative or less than 0, then the process is spontaneous. This is the we have written the conclusion. We can say that until is equal to negative. Similarly, there are two conditions criteria for equilibrium constant, and the next is Deduce the criteria of equilibrium constant when temperature T and pressure P are constant. Deduce the criteria of equilibrium when temperature T and pressure P are constant, or deduce the equilibrium constant in terms of Gibbs free energy. We know that Gibbs free energy is the function of temperature and pressure. The similar is the case here. In such a condition, here the criteria for equilibrium constant T and P is expressed in terms of Gibbs free energy. We know the Gibbs free energy E is the function of temperature and pressure, and Gibbs free energy is defined as G is equal to EH minus TS. This is equation 1, and where EH is enthalpy and it is temperature and EH is entropy. We can write here where EH is equal to enthalpy, T is equal to temperature, and EH is equal to entropy. Enthalpy is given by H is equal to E plus PV. This is equation A. Putting the value of H in equation 1, we put the value of this H in equation 1 here. This is here is H. We put this value of H in here. Then we get G is equal to, instead of H, we get E plus PV minus TS minus TS. This is equation 2. Oh, now we differentiate this equation 2. When differentiating equation 2, then we get dg is equal to dE plus, here we apply chain rule, P dot dV plus V dot dP minus T dot ds minus S dot dt. When we multiply this term, this ts, then we get minus T dot ds minus S dot dt. This is equation 3. From the law of reversal, or from the first law of thermodynamics, this is, we can write from the first law of this is from the formula first law of thermodynamics. Putting the value of T dot ds in equation 3, we put T dot ds in equation 3. We get dE plus P dot dV. This is dE plus P dot dV. When we multiply this minus term, then you get minus dE minus P dot dV. This is dg is equal to dg is equal to dE by dE, P dot dV, P dot dV, B dot dP, P dot dP. Then minus T dot ds is, when you multiply this minus term by, we get minus dE minus P dot dV minus S dot dt. S dot dt, this is similar, same case. This minus d, this term is cancelled out. P dot dV, this is cancelled out. The remaining term is this and this. This is equal to V dot dP minus S dot dt. This is equation IB. At constant temperature and pressure, at constant temperature and pressure, at constant pressure, this term is 0. At constant temperature, this term is 0. Then the result is 0. Temperature and pressure 0 for infinitesimal change. This infinitesimal change means for del. When we apply del, then we say this is for infinitesimal change. For finite change means del is equal to TP is equal to 0, means this is when this del is for finite change, and this del is for infinitesimal change. Now we read what significance. When del G Tp is greater than 0, then the process does not occur and the energy change is positive. Energy change is positive means this is positive, energy change is positive here, and the process is non-spontaneous. And when del G Tp is less than 0, then the energy change is negative. It means it is less than 1. Less than 0 means this is negative, and for the spontaneous, then the process is spontaneous. That is, the process is irreversible. Similarly, when del G Tp is equal to 0, this is the system is in equilibrium condition, and when the system is in equilibrium condition, and there is a reversible process occur. I hope, student, you understand this lecture, and please like, comment and subscribe my channel so that you can get further other videos soon.